so here is homework 8, continuing story of homework 8. We're going to take problem 3. Now we had a bracket, and the U-Heart machine shop has the dimensions of 160 millimeters right here, 140 millimeters up right here, and 300 millimeters in the Z direction. And the applied magnitudes are 20 newtons at A right here, 12.5 at AZ right there, 40 coming this way at B, 12.5 at B in the Z direction, 40 right here and the C, and then 20 coming up right there. Right, so hopefully we balance them all up. We want to find the resultant force, or I meant resultant moment. Maybe I need to change that right there. Let me make sure that everybody, I'll send that out right now. The resultant force. Maybe I do mean the resultant force. Maybe that was supposed to be a trick. We could try to add all those up together, right? Maybe the resultant moment. I think I meant the resultant moment. So I think I'll send out a notification that that was supposed to be different. Let me fix that real quick. So this is my page 3 here, and I am Dr. Deal. I swear, I am Dr. Deal. I even have a degree on the wall that says so. Boom. Okay. And so I'm going to draw this bracket out here. I'm not doing a great job of my I'm going to go down here. Okay. So that way. And there's the email I just sent you, telling you that I updated the thing to ask for the resulting moment and not the resulting force. Well, that's not very pretty. We're going to keep it though. Here is X, Y, and Z, and these are O, A, somehow I put down there, A, B, label it above it, and then C. And I'm going to put dimensions right there. I guess I'll put dimensions right here. So this is going to be my ZAO. XAB in between here, try to make that parallel, and my YBC. Right, and force is applied right here. Let's see. We have a force applied right there, FBZ. On here, we have a force coming upwards of FCY. We have one coming in this direction onto here, FCX. FBX and FAY. And this one is going to be in this direction. This is FAZ, right? Any more on there? Did I get all of them? I think so. And we drew a line in between here to represent, that's the axis about which. So the given, That's the axis about which in part B that we want to get. The given, we say that XAB is 160 millimeters. YBC is 140 millimeters. Should be using these lines right here. ZAO is 300 millimeters. And the applied loads are FAY is equal to 20 newtons. 20 newtons. I'm not going to be able to fit that FAZ in there. FAZ is 12.5. FBX is 40. FBZ is 12.5 newtons. You can see that those two are going to be partners, right? And then FCX is 40 newtons. You can see those two are partners. And then lastly, FCY is 20 newtons, and those two are partners, right? And you can see that now I've changed it to the resultant moment is what we want. You know, I'm almost tempted to do this one using I didn't write what my find was. Let me write that down. I'm continuing that thought. I was tempted to ask what the to do this by way of cross products for all of these, right? And you can instead of using the couples, right? You could use this couples if you just recognize that the couples exist, right? But it doesn't come up a whole lot. And I think it's almost like a shortcut, maybe. So the moment about line OA. And the book I got this, at least the figure from, and inspired by, I don't have the solution manual for it. I could get the Chegg. I could look it up in Chegg and see, but that's usually just somebody from some grad student that's trying to make some money by answering the things, and they don't know what they're talking about. So they don't know what the author's intent was. I would like to know what the author's intent was and how that they would want you to solve this thing. But I'm just going to go ahead and solve it using the couples because that was the topic of today. So I'm just going to say using couples because we happen to know that they exist. The moment about the X right here is going to be from the couple that is made up of, let's see. Wait, is there going to be any about? Yes. No. Let me look at that. I don't think so. Doesn't look like there's going to be any moment about the X. Double, triple check-in. That right there doesn't have, it's going to be 0. Go figure, all right? And so now the moment about the Y, that's going to have a couple, all right? So we're going to have this guy and this guy are going to form a couple about the Y, and it's going to be counterclockwise, so that's good. And is there anybody else? This right here is going to be about the Z. This one right here and that one is going to be about the Z. So the only two that are going to make a couple about the Y is this guy right here. So we're going to take that FBX, and it's going to be 40, and it's going to be times that XAB. at 160, but I'm going to use 0.16 because I would prefer to have so it's going to be 6 point. I would rather have Newton meters, right? And then mz right here, right? So mz, that couple is going to be made up of two parts, this guy and this guy, right? So you can see that that's going to be another. Wait a minute, did I just say 40? I think I just did something wrong here. Let me see here. FBZ was 12.5. I messed that up. Sorry. All right, so FBZ is 12.5. And by the way, this is plus right there. That is. So what's my 12.5 and 0.16? So we're going to get a 2 Newton meters about the about there. Okay, so 2 Newton meters across there, and then for this one, okay. So now let's go back. That one goes. It's making something. This one and that one, because it's the AZ, and these two right here are the ones that are causing something about the Y. And now let's see what let's start with this one. 20 right here and 20 right here. They go about the Z, and they are going counterclockwise, right? So that's trying to make it come around this way right here. So let's make that that is the this one right here. This is the one I just said, right? Yeah, the 20. And that distance is also XAB. All right, so that 2 is going to be the 0.16. All right, so 20 and 0.16, which you should be able to do in your head. That's whoop, I'm not done. Sorry. That's part of it. Now the other one, right? So the next one is going to be the CX, right? So the one in the X direction, right? And that's going to be, and this BX, that couple between there, is going to be the CX times the one right here. So, and that too is going counterclockwise. Okay, so that's the 40, and it's going to be times this 0.14. And so that's going to be 40 and 0.14. I should be able to do that in my head too. I'm going to add those together, and we're going to get 8.8 Newton meters. So the answer to this right here, the resultant moment, if you will, is going to be a 0I plus a 2J plus an 8.8 K Newton meters. That's part A, right? Normally I wait to the end to box these things, but I'll put it in right in here. I wrote it out so nice and neatly. Okay, and then for this next one right here, what we need to do to be able to find the moment about this line, right, OB. I said OA, I meant OB. No, they want it about OA. They do want it about OA. Okay, that makes it like really easy, right? Because the direction cosine of OA right here, and this is going to be messed up. Damn. The direction cosine of this is just going to be 1I, right? It's like another trick question. I already sent out that email, so I'm not going to send out another email. The moment about line OA. I meant OB. I think I meant OB. All right, well, I'm not sending out another email, and I'm not fixing it. So the moment about OA is just going to be this right here. And it's going to be 0, right? Because this obviously is 0j plus 0k. So when you do this dot product, you get 1, 0 plus 0, 2 plus 0, 8.800 equals 0, right? So part B is moment about A. I don't really intention to make this a trick question, and I don't know if I don't know. I don't know if that's right to leave it the way it is, but you've been worked hard. You deserve it. You deserve a good one, although this might drive you a little nuts. Trying to find out what the fair thing is. We're gonna leave it.